All right, let's go ahead and get started with section 1.7. It's all about linear inequalities. So linear means what again? Yeah, straight line. What does it mean about my variable exponent? What's the exponent of my variable for straight lines? 1. Very good. All right, so what's the purpose of inequalities? Sometimes you don't know if things are equal or not. You just want to know if one is larger or smaller than another. And so we have these new signs, greater than, less than, greater than or equal to, less than or equal to, instead of the equal sign. The solution set, when it says to solve an inequality, you need to find all the values of the variable that make the inequality true. All right, so let's talk about that when we do one problem. We're going to solve them just like we solve equations, meaning we want to isolate x, get it by itself. So what's the first thing I would do here on this problem? Combine the x terms, right? So should I subtract 7x or subtract 2x? Yeah, so both are valid, but this would leave us with a positive number. And at the same time, let's go ahead and subtract 4 to put the constants on the other side. All right, that gives us 7x minus 2x is 5x, is less than negative 6 minus 4 is negative 10. And to get x by itself, divide both sides by 5, and x is less than negative 2. All right, let me ask you a tricky question. How many solutions does this have? 2? A lot, infinite. All right, so is it true that 0 is less than negative 2? 5. No. Negative 100. 0 is not true, right? Okay, so there's infinite solutions. We need to somehow represent all infinite of these solutions so that someone can eyeball it and know what they are. Okay, so we do that in a few ways. Interval notation, set board notation, and graphing. Okay, so first, let's talk about graphing. If we graph this on a number line, x can be any real number. Which of them are true? If I plug in 0, negative 1, negative 2, negative 3, I'm talking about the values to the left of negative 2. The value's smaller. Because if I plug in negative 3, it's true. If I plug in 0, it's false. Did anyone work ahead and do this assignment? Okay, when you graph it, does it want open circles or parentheses? Yeah, so for a strict inequality, open circle, or does it graph it with a parenthesis? Opens? Your has parentheses? Pass you really quick. Oh, they offer both? Okay, so I'll do both. Parentheses and open circle means negative 2 is not a solution because negative 2 is not less than negative 2. It's equal, right? Can't be smaller if it's equal. Okay, so that's what the parentheses mean. How does this differ from solving an equation? What's that? It's not equal, but in terms of solving it, there's one thing we need to take special care of. Let's look at a number. For instance, negative 2 is less than 5. You agree? Actually, I'm going to say 6. Do we agree? Okay, an equation, I could just divide both sides by the same number. What if I divide both sides by negative 2? Negative 2 divided by negative 2, 6 divided by negative 2. I get 1 and negative 3. Which one's larger? 1 is larger. The new rule is if I divide by a negative, I need to flip the inequality. So that's the only new rule. And you know what? I don't mind if you flip equal signs. If you want to be consistent. All right. Any questions about this? All right. When this gets very tricky is things in the future we'll see of this form. X squared is less than x. Okay. In this type of problem, actually, let me change it. Let's do a fraction. X squared minus 1 over x is less than x. Okay, do you remember what we did when this was an equation? X squared minus 1 over x is equal to x. Do you remember how we solved these? We multiplied by x, right? And that's perfectly valid for an equation. But we may have created an extraneous solution, right? Turns out you cannot multiply this by x. Cannot multiply by a variable. Because a variable represents positive and negative numbers, so do I flip the inequality or not? It's indeterminate, right? We cannot multiply by variables because variables represent both positive and negative numbers. So it's nonsense. Okay, so be careful about this. We will learn to solve these later on in the quarter. All right, this next equation, how do we isolate x? All right, so divide by -3/8. More simply, multiply by the reciprocal. Okay, let's multiply both sides by -8/3. And because we multiplied by a negative number, this greater than or equal to flips to a less than or equal to. Okay, the left-hand side, when you multiply by the reciprocal, you get 1. 1x is just x, is less than or equal to what? Let's reduce it. 3 goes into 9, how many times? And 8 and 14 have a common factor of what? 2. So 8 divided by 2 is 4. 14 divided by 2 is 7. Negative times positive is negative. 4 times 3 is 12. 1 times 7 is 7. Okay, so graphically speaking, I have, can you find -12/7 on number line? I'll show you a really easy way. You make a line and you call it -12/7. All right, do we shade to the left or to the right? Left hand. So values like -100 or +100, what would make this right? Correct. Value like -100, so to the left. Okay, and then do I use an open circle or a closed circle? Closed circle if it has the equal sign under it, because -12/7 is equal to -12/7, which means it's also less than or equal to itself. Okay, or I guess it accepts brackets on the Alex homework system. Any questions about that? Next, we'll practice translating a solution set to interval notation, set builder notation, and graphing. It's probably easiest to graph first. Are my solutions to the right or to the left of 2? So you just pick a large number like 1,000. Is 1,000 greater than or equal to 2? Then I shade to that side. Is -1,000 greater than or equal to 2? No, so I don't shade that side. So I shade to the right, and I say 2 is a solution. I'm going to use a closed circle to indicate that 2 is a solution. Or you can use a bracket. All right, interval notation is always from smallest value to largest value. So I look at my shaded region and I go all the way to the left and I say it's bordered by 2. It's bordered by 2, and to include it, I use a bracket. I use a comma to say, now all the solutions are the values from 2 all the way to, and I go to the end, and where does this go to? Infinity. Positive infinity. Is infinity a number? No, it's only something we can approach. So we do not include it. We do not use a bracket. For infinity, we always use parentheses to say we're going forever closer to it, but never getting there. So in set builder notation, we're going to write x such that x is greater than or equal to 2. Any questions about this? So just note that set builder notation is very similar to the regular inequality that you solve. This just means all real numbers x. This line means, let me do a different color. This line means such that, and this is the statement we want to be true. x is greater than or equal to the number 2. The set builder notation is shorthand for entire sentence. X is greater than -4. We find -4 on the number line. Maybe I should draw 0 and -4. Do I want to shade to the right or to the left? Is 10 or -10 a solution? Is 10 larger than -4? Yes, so I should shade that side. 10's over here, so I should shade over here. All right, is -4 a solution? Is -4 greater than -4? No, so we use an open circle for a strict inequality. There's no line under it. I call it a strict inequality. Okay, so in interval notation, what is my leftmost boundary? The smallest number. -4. Yeah, so -infinity is over here. But in terms of the shaded region, -4 is the smallest all the way up to what? Positive infinity. And is, okay, parentheses because -4 is not a solution. And infinity because infinity is not a number. -4 to infinity. Okay, so what if I have interval notation? Can I write it as an inequality? We usually graph first. Let me plug in some numbers here. Here's 3, 2, 4. And do I shade to the left or to the right of 3? If my solution set is from -infinity leftmost to 3. So I should be shading -infinity all the way to 3 and not include it. Okay, so this answer will be x is less than 3, strictly less than. Does this look familiar? Have we seen this before? Okay. So x is less than or equal to -8 is similar. What the only difference will be it's a closed circle now. So here's -8, here's 0, and I now have a closed circle, and I shade to the left. So in interval notation, of my shaded values, what is leftmost? It goes forever to the left, so -infinity, and rightmost, bordered by -8. And do we include it with a bracket or exclude it with a parenthesis? Bracket. All right, very good. All right, we have another inequality here. 3 is less than x, which is less than or equal to 5. In set builder notation, you just repeat that. 3 is less than x, less than or equal to 5. And we shade, do we shade to the left of 3, between 3 and 5, or to the right of 5? What values make this true? Okay, what's your favorite number between 3 and 5? That's really predictable. No fractions? Okay. Do I use an open circle on 3 or closed circle? 3 strict inequality, so that's an open circle. And on 5, closed, very good. Okay, so interval notation, it means our solutions are between -1 and 2. So I'll graph, here's 0, 1, 2, -1. I want to shade the region between those. -1 is a solution. Oh no, undo. -1 is a solution. Why does my stuff erase when I draw over it? And 2 is not. So we say that x is between 2 and -1. And I write a line under the first or the second. So the bracket corresponds to the less than or equal to, parenthesis corresponds to this. We need to be slightly careful with these type of problems because you can have a statement that's absurd. Actually, I'm just going to flip to inequalities. Can anyone tell me why this is absurd? Even though it looks so similar to one right above it. Yeah, that's right. You can't be smaller than -1 at the same time greater than 2. In fact, this is implying that -1 is larger than 2. Does that make sense? So this is an automatic No solution. All right, let's try compound inequalities. How can we combine these? You can either take the intersection or the union. Let's see. Are you familiar with these concepts? Okay, if I want peanut butter and jelly, that means I have to have both, right? If I want peanut butter or jelly, means I can have all peanut butter and it's fine. All jelly and it's fine. Or means if one of them's true, it's fine. And means they both must be true simultaneously. Can we memorize that? For an or? What is the symbol for and? Yeah, the rainbow, the upside down U. What's the symbol for or? The U without a leg. Union. Okay. We're going to use these symbols with interval notation. And we'll go ahead and use the words when it's in an inequality form or set blower notation. All right, let's solve the first one. How do you get x by itself? All right, so we multiply both sides by 2, we get x is greater than -4. Do I have to flip the inequality? I multiply by +2, so no, I do not. I should keep this word and in between and then solve the next one. How do you get x by itself? Divide by 5. X is less than or equal to 2. Okay, and means we want both of them to be true simultaneously. So if I graph it, I want the overlapping region. And means the overlap. Let me graph. Okay, now I should write more values. Here's 0, -1, -2, -3, -4. Here's 1, here's 2. Do I shade to the right or to the left of -4? To the right. So you want this to become second nature. I'm going to draw it above my graph. I found 2. Do I shade to the left or to the right of 2? To the left, and this needs to be a closed circle. The overlapping region, so if I compress these, do you see where they overlap? It overlaps only between -4 and 2. Here's the tricky part. Do I use an open circle or a closed circle at -4? Is -4 a solution to both? No, it's not a solution to the green one. Therefore, it is not a solution to both combined. So it needs to be a solution to both. Is 2 a solution to both? Yes, the green one is shaded and there's a solid dot for the purple one. Therefore, our solution in interval notation is what? So the leftmost boundary is -4. The rightmost boundary is, we separate by a comma. Do I put a parenthesis or bracket around -4? Parenthesis, very good, because, and bracket around 2, because it is a solution. This represents all infinite solutions that make both original inequalities true at the same time. Any questions about that? All right, here's a trick question for you. What if I change this to or? Looks quite similar, has the same graph, right? What's my solution set now? So if one of the equations is true, it's in the solution set to the or expression. Very good. If anything is shaded at all, and since they overlap, everything is shaded, so all real numbers, the infinity to infinity. Because the purple line covers everything to the left, the green line covers everything to the right. Everything is shaded at least once. So one of them will always be true. All right, I'm going to skip this one because I want to get to the more difficult ones. Are these more difficult? Yes, they are. Okay, let's solve the one on the left. What should we do first? Distribute 3x minus 6 plus 2 is less than or equal to x minus 8. Is that right? No, that's a 2. I don't distribute to that 2. All right, Let's subtract x from both sides. Do I need to flip my inequality? No. I can add or subtract anything. Maintains the same balance. Let's add 4 to both sides. And we get 2x is less than or equal to, what am I doing? Add 4 to both sides. 2x is less than or equal to -4. How do I get x by itself? Divide by 2. X is less than or equal to -2. You guys are checking if I make mistakes, right? Okay. Does it look okay? Very good. The next one. What should we do first? Distribute. 4x plus 4 plus 2 is greater than -2x plus 4. Let's go ahead and add 2x to both sides. 6x plus 6 is greater than 4. Let's subtract 6 from both sides to get 6x is greater than -2. Divide by 6 to get x is greater than -1/3. Did I make any mistakes? Okay. Personally, when I do a test, I do make a lot of mistakes, so I double check every step as I go. But since I have 35 eyes checking me, I'm going to assume that you guys will find it. All right. Should I shade to the left or to the right of -2? To the left. Very good. I should be precise about graphing these. Here's 0. Here's -1. Here's -2. And I was told to shade to the left of -2. And I put a solid circle there. -1/3. If I split this into thirds, -1/3, I should shade to the right or to the left of -1/3? To the right. Or means if one of them is true, the whole or statement is true. On this number line, this is shaded by the blue. At least it doesn't have to be shaded by the green also. This is shaded by the green. It does not need to be shaded by the blue also. That's for and. My solution set, I need more room again. Let me minimize this again. Is all the red shaded region. The left arrow is from where to where? Like this? This is wrong. Okay. It's always from smallest to largest. -infinity is smaller than any number. So I should always go left to right, smallest, -infinity to -2 is ordered. And -2 parenthesis or bracket, it's included. I have the disjoint statement from -1/3 to infinity. These are both parentheses. Because it's interval notation, what goes between them? The union, as opposed to the word or. Or for inequalities, union for interval notation. Any questions about this? Note that these two problems are exactly the same, except for what? There's an and between them. From that graph, what's the overlapping region? There is none. So what's the answer? No solution. If you're lazy, you can write this Greek symbol, meaning no solution. So there's no value of x that will make both inequalities simultaneously true. Any questions about that? Let's try the next one. How do you isolate m? Good. Multiply both sides by the reciprocal, which is -5/4. So that cancels out with the -4/5 to make 1, which means 1m. We get m by itself. Oh no, I made a terrible mistake. What have I done? What have I done? I don't know if I can trust you guys to catch my mistakes. Yes, I multiplied by a negative number. I must flip the inequality. M is larger than -10, or, oh, this is a calculator course. I don't have to compute this by hand, huh? What did you get? on your calculator? M is greater than or equal to what? Oh, that's nice. 2.5. Maybe I'll write it over here. Divide both sides by 0.34. I'm going to write the or down here. And that gives me that M is greater than or equal to 2.5. Let's see here. Here's 0. Here's approximately 2.5. Here's approximately -10. Should I shade to the right or to the left of -10? To the right of -10. Open circle, shade to the right of -10. Should I shade to the right or to the left of 2.5? To the right. It's tricky when M is on the other side, possibly, but the M is larger, so we shade to the right. Okay, now the arrows are going in the same direction. If we answer or, what's our solution set? If anything is shaded at all, we include it. I should shade to the right of what number? Very good. To the right of -10. So our solution set is -10 to infinity, parentheses. Any questions about that? Very good. That's our next problem here, number 10. If we want the overlapping region, the and meaning overlap, we should shade, here's -10, here's 2.5, for shading to the right of -10, shading to the right of 2.5. The overlapping region, that is correct. To the right of 2.5. Do I include 2.5? Yes, because it's a solution to the blue one and to the green one. So in interval notation, 2.5 to positive infinity, bracket around 2.5, parenthesis around infinity. Are you familiar with how to solve a three-part inequality? We want to isolate x, so you should undo the multiplication by -3, undo the addition by 9. Which should we undo first? We get rid of the +9, and so we do what? Close. Subtract 9 from all three sides. Okay, so we get -3x. Inequality signs stay the same. And we have, it's between -15 and -9. What's our next step? Divide by -3. What do we think? Yes. We flip all three signs. So for an equation, I typically write the -3 down below here. I'm not going to write it for inequality. I'm going to write a new line because I have to flip to inequality. Becomes a less than becomes a greater than. Less than or equal to becomes a greater than or equal to. Divide all three by -3. What's -15 divided by -3? +5 is larger than x, which is larger than or equal to 3. Does that make sense? Yes, number line. 3, 5, shade between. 3 is bracket or closed circle. 5 is parenthesis or open circle. And interval notation. Just be careful to write the 3 first, 5 second, bracket around 3, parenthesis around 5. Can anyone do the next one in their heads? Why is it no solution? Why can you tell right away? It's implying -2 is larger than 4, right? That's false. No solution. All right, that brings us to absolute value inequalities. Have you seen these before? Okay, so the way we're going to interpret this is distance from 0. So x is the unknown, and we're asking what is its distance from 0? Absolute value x is asking what is the distance from 0? Maybe it's not saying it. It's saying the distance from 0 is less than 5. So if I draw a number line, here's 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, -5. If x is 0, is it true? Is the absolute value of 0 less than 5? Okay, what if I have -3? Yes, and the distance would be 3. Because that distance is 3, it's less than 5. What if I pick 4? Is it true? What if I pick 6? False. 7, false. -6, false. It's saying from 0, I can go 5 to the left, 5 to the right. Everything in between. Okay, but I'm not going to just have an x in the middle. I'm going to have a whole bunch of other stuff. If x is in the middle, then I would just say x is between 5 and -5. Are there any questions about this? If the absolute value is less than a positive number, we're saying that expression x is between +5 or -5. So what if its entire expression, e, is less than or equal to k? It's between -k, +k. That entire expression. Okay, which of these first two falls under that scenario? The first one or the second one? The distance from 0 is less than 2, meaning it's a small distance, less than 2. That means whatever's on the inside, the shortcut, x minus 1, must be between 2 and -2. So this is the shortcut how we're going to solve these inequalities. You need to somehow write it without an absolute value by interpreting the distance from 0. How do you isolate x? Add 1 to all 3 sides. And we say x is between what and what? 3, -1. Every value from -1 to 3. Open parentheses. That looks a lot like an ordered pair to me. So I'm going to label this an interval so people know it's an interval, not an ordered pair. All right, any questions so far? So how do I represent this? Absolute value of x is larger than 5. 0, 5, -5. Now I'm talking about solutions will be these values that are far away from 0, further than 5 away, or further than 5 away on the other side. Any questions about that? So how do I represent this as an inequality? X is less than -5, or x is larger than 5. I'm going to split this up into a disjoint inequality with the or in between. Any questions about that? So problem 2, it might be easier to flip this inequality. Absolute value 5 minus 4x is greater than or equal to 13 is the second scenario. My distance from 0 is large. It's greater than or equal to 13. I'm far away from 0. So that means that whatever's inside the inequality, 5 minus 4x, it's either less than or equal to -13 or what? Or far away from 0, which would mean 5 minus 4x is greater than or equal to +13. That will be further from 0. Less than 13 would be going towards 0. So first you have to recognize it's an absolute value inequality. Then you need to decide, are we talking about values close to 0 or far from 0? All right, we solve. If we subtract 5 from both sides, -4x is less than or equal to -18. X is less than or equal to, no. I need to flip the inequality when I divide by -4. X is greater than or equal to 9/2, or if we or subtract 5 from both sides. Negative 4x is greater than or equal to 7. X is, and we divide by negative 4, less than or equal to negative 7/4. This is the smaller one. This represents negative infinity to negative 7/4. Include the bracket. This is the larger one. I need to write it in order, 9/2 to positive infinity. We write the union in between. Did I subtract instead of dividing? Wait. It's not. Which one? This is 8. Thank you. So 8/4 is negative 2. Is this right now? Thank you. All right. Absolute value k minus 3. You did last night's homework. What was your answer to that? If it equals 0? Just the one solution, right? K equals 3. All right. This one will have the solutions where k minus 3 is between. No, sorry. This one's a trick question. Absolute value is always what? Positive or 0? So this is no solution. It cannot be negative.
In this third scenario, it's a combination of the other two. So guys, if you take the union of the solution sets k equals 3 and no solution, you once again get k equals 3. For the fourth scenario, absolute value of k minus 3 is greater than 0 and greater than or equal to 0. An absolute value is always greater than or equal to 0, no matter what. So this would be all real numbers, negative infinity to infinity. And the scenario above it, we just have to throw out the case where k is equal to 0. So from all real numbers, we're going to throw out the case that k equals 3. That would be all the numbers from negative infinity to 3. You don't include 3. So I put parenthesis, union, the values from 3 to infinity. And once again, we do not include 3. All right. We have another type of problem. It's just really using logic once again. So absolute value of whatever is always greater than or equal to negative number, no matter what. Just like it's always greater than or equal to 0. So this solution set also is all real numbers. Where can we apply some of the stuff we learned today? What is the domain of a function? Those are all the values of x for which you could plug in, and it makes sense. So we just can't take the square root of a negative number. In this case, we would say the domain is all the values of x that are greater than or equal to 0. And that's so that our function spits out a real number as opposed to a complex non-real number. So the domain of f is all the values from 0 to infinity, including 0. Okay, g is slightly different because inside the radical, we have an expression x minus 6, and we know that expression must be greater than or equal to 0, or the square root will not be a real number. So we add 6 to both sides. X is greater than or equal to 6, and the domain is all the values from 6 to infinity. That's the domain of g. The domain of h is slightly different here. That is all the values for which 6 minus x is greater than or equal to 0. You take the entire expression under the radical and set it greater than or equal to 0, and you solve. So we subtract 6 from both sides, and we multiply by -1. So we flip the inequality. So in this case, we're saying all the values of x that's less than or equal to 6. In other words, the domain is from negative infinity up to 6, including 6. For a cubic, turns out you can take the cube root of a negative and get a negative, take the cube root of 0, or a positive and get a positive. So the domain for a cube root, in this case, is all real numbers. The domain k would be, and actually the way we're going to denote that is d sub k. The domain of function k is equal to the set from negative infinity to infinity, all real numbers. I should denote this domain of h also. Finally, we have m of x is the fourth root of x minus fixed. And one way to think about this would be what to the power of 4 would give us x minus 6. Okay, and that's the m function. What is the value spit out? And it turns out you can't get a negative if you raise to the fourth power, just like a square. So if it's an even root, that domain must be greater than or equal to 0. So just like with the square root, we set this domain x minus fixed greater than or equal to 0, in which case x is greater than or equal to 6. So the domain of function m is equal to all the values from 6 to infinity.